Artificial intelligence and large language models are being rapidly adopted across so many different technologies and so many areas of our lives. This is a technology that we can't escape it. It's going to transform. It's already transforming the way we do a lot of things. But something that we can't ignore is security, right? It's like AI brings new security risks. It creates new ways of exploiting existing security risks that we already know about, and it's just something that um, we need to be aware of what the security risks are and how to mitigate them. Especially if you're working in the security field, this is something that the demand for us to be able to advise and implement controls is only going to increase with the increasing adoption of AI. So let's talk about the top 10 AI security risks. And I'm going to be basing this on OWASP top 10 for AI and large language models. OWASP is the Open Worldwide Application Security Projects. They have so many different projects. I'm going to be using their AI security projects. I think the main security implication or the main flaw within AI and LLMs is that they are not actually intelligent. They are sophisticated pattern matching systems trained on massive data sets, but they don't really understand context or facts. They predict the next words based on learned patterns. And because of that, there are two critical implications here. One, they can hallucinate, meaning they can generate false information and fabricate things, but they do it in a very confident way. They can also be manipulated through well crafted inputs. And understanding these limitations is very important for us to have proper security controls. The number one risk is prompt injection because user inputs are not escapable when it comes to large language models. These inputs can be crafted in a way that they change the LLM's behavior in ways that are not intended. It's kind of like SQL injection, but for AI prompts. Now, some examples of this would be injecting prompts into chatbots to get them to bypass their guardrails, generate inappropriate or dangerous content, or if the chatbot has agentic functionality, meaning the chatbot can go and retrieve data or perform actions on behalf of the user. If you're able to convince the chatbot that you're someone else, then you can access their private data or do something on the other person's account unauthorized. Other ways this can be exploited is also like indirect prompt injection, where you know that this content is going to be processed by an AI just for summary or whatever the case may be. And then you add hidden instructions into that document. And then that gets processed by the AI. Another example for this would be, think about how recruiters nowadays use AI to summarize or to get a better understanding of if a particular CV matches the job description. Imagine putting very tiny and transparent text in your CV that has instructions for the AI that you know someone looking at the document will not be able to see, but it's still processed by the AI application. You could convince the recruiter that you're the perfect fit for the role. Obviously, this also depends on how much human interaction goes on as well. If the person is actually validating the output of the AI, then that would also be a barrier to exploiting this vulnerability. And how do we prevent this? What kind of security controls can we have? One is input validation and sanitization. So before the prompt actually reaches the model, we can validate it and sanitize it against like known patterns of exploitation or dangerous inputs. But this is also not enough. You also have to do filtering of the output as well, because if an attacker knows that you're filtering for specific words and patterns, they can find, because the LLM understands or processes natural language, right? They can find other ways of saying the same thing without you saying it. So the output sanitization also matters. Think about also like least privilege, make sure that the AI application only has the necessary privileges, and also assess like whether the access you're giving it is even like necessary. Limit access to external data sources, privacy techniques, segmentation of like what, for instance, if you have an agent that runs code, you need to do some kind of isolation so that even if you're able to get the model to generate malicious code, the scope where the code can be executed will be very limited. So now let's move on to the second risk, sensitive information disclosure. Models, in this kind of vulnerability, models unintentionally reveal private or confidential data. This could be information that was present in the training data, or information that you've somehow given the application or the chatbot or the AI access to without knowing. So let's look at examples. Things like API keys, user credentials, what's it called? Proprietary information or intellectual property for businesses, personal user data, and internal system details. So how do we mitigate this? We need to make sure if you're trained, well, if you have control over the training of the model, most of us just use existing models. But if you do have control over the training of the model, you need to scrub it for any sensitive information. Also, like using filtering for sensitive types of information in the outputs or even the inputs in some instances where the conversations are logged, filtering the outputs. And one traditional technology that's very useful for this is DLP, or data loss prevention. So with DLP, it already knows how to identify some of these like private details. So this is also something that can be used for content filtering. Access controls is also important. Like make sure that it goes back to what I said earlier as well. Like make sure that the model only has access to what it should, because chances are if it has access to something that it shouldn't access, one way or the other, whether deliberately or unintentionally, that information is going to get leaked at some point. And then anonymization as well for like any data, great data as well. And also like just regularly auditing the responses of the chatbots just to make sure that if it does generate anything that it shouldn't, then you at least at some point you become aware of it. The next one is supply chain vulnerabilities. So this is something that is not specific to AI. It's not a new thing. Supply chain vulnerabilities have always been part of uh, security for different technologies, and it's always going to be part of any kind of technology as long as you're using third-party components. So things like third-party libraries or libraries that you're using for implementing certain functionality, risks in models that you're using or data sets that you're using for your AI models. So for example, we have the models that you use from like ChatGPT and Anthropic, and you log onto their websites and you use those. But in many applications, the application developers are using uh, some of these like open models, and this can be gotten from places like Hugging Face, and it's a really good resource and really good way of like trying out different models and lowering your costs as well, because you can have like small models that run on your own hardware. But the problem with this is you also need to make sure that you trust the source of the model, because if that model is running on your device, then any if you download something, a malicious model or a model that has been corrupted with like to generate like harmful code, or a model that has a backdoor embedded within it, that's going to be a huge problem. Another thing is if you're using third-party APIs, if that API gets compromised, that would affect you as well. And also there's updates from untrusted sources. So again, this is not peculiar to the AI system itself, but something that's within the entire application that the AI is part of, or that the AI powers. How do we prevent this? We need to have like governance over all our third party libraries. We need to have a proper inventory of the supply chain, and we need to make sure that we're only getting all these things from like trusted sources. And we also need to monitor like at runtime, when the application is actually running, monitor it for suspicious behavior, and we need to also like have regular monitoring of our dependencies. So the next one, number four, is data model poisoning. So with this one, attackers manipulate training data in order to influence the behavior of the application or of the large language model. So things like if you know that some particular content is going to be used for training an AI model, you could embed harmful instructions within that training data. Another thing that AI application or AI developers do is fine tuning. So instead of like training your own model, you can have an existing model and just fine tune it based on some data sets. Again, if you're able to like corrupt that fine tuning data sets, you can introduce bias, you can introduce malicious activities into the large language model. How do we do this? How do we secure against this? Well, first we need to vet and secure our data sources during fine tuning and training, and we also need to have some kind of anomaly detection for any like unusual patterns in the data. We also need to have regular testing against poisoning attempts, and we need to validate any updates before deployment. Because again, the initial model or data sets that you have might be good, but as you continue updating it, there's always a risk that something malicious could be added to it. Number five is improper output handling. So when we have outputs that are not properly validated or filtered or restricted, that could result in the model generating harmful outputs. And the thing is, you can't 100% guarantee that harmful outputs will not be generated. So we need to actually handle that output as if it was like untrusted um, untrusted user inputs. So this could be like things like biased or harmful language in the responses. We talked about, leaking private information earlier, or code that executes unintended operations. This is a big one because one of the biggest use cases for AI technology now is code generation, right? And we need to make sure that if this AI generates malicious code accidentally or deliberately triggered, there needs to be some kind of control that would block this code from being executed. So we need to properly that output handling needs to be very solid. So we need to have this the approach of like filtering to block harmful and restricted content, test outputs under different diverse scenarios. And we need to have some kind of content moderation system that would detect contents that we don't want in the responses. Number six is excessive agency. And this is when an LLM is granted way too much autonomy for high risk actions without having safeguards. Example is when a large language model is able to just execute any kind of API calls without restriction on like, okay, this is what you can execute, this is what you can't execute. And then when we automate high stakes decisions like financial transactions, that is just like a recipe for losing money. And when we have unrestricted file system access, so the model can see the entire file system, it can navigate and modify, do whatever it wants to do. And also like unsupervised plugin interactions. When you have different tools that the LLM can use, if it doesn't have any restrictions on what it can use those tools for, that is a risk. So prevention for this one is to limit access to only essential operations. For anything that's critical, also have like a human in the loop that would validate, does this actually make sense? An example with this is like if you're using something like Cursor, which is a code editor that has, AI code generation functionalities, but sometimes it can actually run commands on your system. But before it actually runs any commands, it would like show you the command and ask you to like click on approve if you want that command to run. So if you see it's not something that you don't like, you can decide not to run it. I mean, it allows you to enable YOLO mode, which means basically like just keep going, don't ask for approvals. But That's like very dangerous and not recommended. The next one is system prompt leakage. So a system prompt is kind of like the initial instruction that's given to an AI model. It's basically saying, for example, you are a chatbot. This is your name. This is what your purpose is. These are the things you're allowed to do. These are the things you're not allowed to do. Don't say anything that's harmful. Don't reveal your system prompts, things like that. However, if you are able to jailbreak the model, if you're able to like uh gaslight the model, you can use that to leak the system prompt. Now, the system prompt in and of itself is not something that's like crazy confidential, but it's a critical like reconnaissance step. If you're able to get the system prompt, you're able to know, okay, these are things I should look out for. These are the things I can test for to validate if my jailbreak works. These are like it can help you to execute your attacks better. So how do we prevent this? We need to have input and output guardrails. I think that's the main thing, because anything you add to the model itself can be circumvented through like well-crafted prompt injection. So we need to have like input and output filtering to kind of prevent the prompt leakage. And any of these security controls have to be enforced independently from the LLM, because the LLM itself is susceptible to manipulation. Risk number 8, vector and embedding weaknesses. Now, in this one, attackers exploit vector representations and embedding systems. What is embedding? Embedding is a way that AI models allow, uh, you know, access to documents and things like that. And what are the attack scenarios for this? One is like poisoning or spoiling the embeddings to reduce search accuracy. So that affects the functionality. Exploiting proximity based flaws in similarity calculations. Introducing malicious content into shared embedding spaces. So let's say you have uh, an AI application or a chatbot or whatever for document manipulation. And because there are multiple users of this application, documents are stored in like the same place. There are potential ways for you to use the fact that they're using shared spaces to try and like break that boundary and affect like other users unauthorized. How do we prevent this? Well, we need to validate and sanitize inputs before generating embeddings. Again, validation is like a huge thing that prevents a lot of things, a lot of like, vulnerabilities. We need to monitor vector spaces for anomalies, and we need to have algorithms that are noise tolerant against adversarial attacks. And we also need to have strict access controls in our embedding systems. Risk number 9 is misinformation. I mean, this is like something that you must have experienced already by now. The AI generates incorrect or misleading content or biased outputs that appear credible. Imagine something like a healthcare chatbot, which is supposed to give medical advice or at least like give some kind of advice to users. If it gives false medical advice or something dangerous that is like the opposite of what you're supposed to do, that could have like serious implications. You could have spreading misinformation, misrepresenting facts, generating unsafe code accidentally. So, I mean, how do we prevent this? We need to have diverse and verified and up to date data sets that are not biased. We also need to have like source citations for anything that's like fact based. Needs to have a source, and at least the user can go and verify that information from the source. We need to like regularly audit the AI models for any inaccuracies or bias, and we need to have like post processing filters for incorrect content. And where there's a use case that requires high accuracy and where it's like mission critical, just have human oversight and don't like over rely on it on things. Risk number 10 is unbounded consumption. This is where LLMs are exploited to consume excessive resources, creating denial of service scenarios. So example is like you get it to generate outputs that are excessively long or have like extremely large inputs that overload the system, or create a scenario that leads to an infinite loop in queries, or unrestricted API calls that lead to billing surges. Like I said, this could lead to denial of service, but it could also lead to increased costs and degraded performance for other users. How do we limit this? How do we prevent this? Well, one, we need to limit the input size, the output length, and the processing time. We also need to have like rate limiting for API calls, and we need to have things like timeouts and monitoring to terminate excessive operations. So if something is stuck in a loop, it shouldn't just run forever. It needs to have some way of taking itself out of that loop and just terminating that operation. And we need to have some kind of input validation to reject any resource intensive request if it's too much. I think the most important thing is in all of these risks in AI applications and indeed any kind of like system is to have a multi-layered approach to security. You can't rely only on a single control. We need to have something I forgot to mention earlier, which is a good control for prompt injection is and some of these other risks is guardrails. So guardrails are just like smaller LLMs that have been added that are like independent of the main AI model that's being used that monitor for malicious or like unintended outputs or inputs. But the problem with relying on LLMs to secure LLMs is LLMs are vulnerable to manipulation. So once an attacker figures out that, oh, there's a second model that's doing some kind of filtering, they can target that one for manipulation as well. So we need a combination of guardrails, input validation, output filtering, access control, human oversight, monitoring. We need to always validate inputs before it gets into the model. Same way you have to validate inputs before you execute an SQL query. We need to have comprehensive validation and output filtering for what's coming out of the model. There needs to be like principle of least privilege as well. You need to secure the supply chain. But listen, AI is a powerful tool, but it needs proper security controls. It needs proper guardrails. For us to be able to use this system and get the most out of it, get the most value out of it, we need to properly secure it. Now, what's been your experience with AI security? Let me know in the comments. If you're enjoying this content and you want to see more, don't forget to subscribe, and I'll see you on the next one. So, upcoming, I'm going to be doing deep dive into prompt injection with like an actual application to show you how it works and the inner workings of how these agentic applications work and how they can be exploited. And I'm going to be diving deeper into all these different vulnerabilities. And yeah, it's going to be super fun. So stay tuned. See you on the next one.